Hello, everyone, and welcome to the Cloud Lunch and Learn weekly sessions. Good morning, good afternoon, good evening, depending where you are located and watching us. Today, we have a great session with Robert, but before proceeding to the session, I'm going to just share with you the usual QR codes. So you can scan these QR codes or even use the URL provided in the slides. I'm going to also post a message for you. So by registering to this session, you will, of course, access relevant materials provided by Microsoft. So then you can take your journey after this session to just continue your learning about Terraform, okay? Given that, I would like to just welcome Robert. Hi, Robert, how are you doing?
Hi, thanks for having me.
It's a pleasure for us to have you here. Do you want to share with us what are you based on?
Yeah. So, well, I'll go a little bit into detail on me in just a little bit, but basically, I work at Crayon in Oslo, in Norway, as a cloud architect, which just means that I do cool stuff, I think. So, mainly working with Azure, but also things like, Terraform and infrastructure as code and cloud native tooling. So,
nice. So, I'm going to just post the message in the chat so you can use the link to just basically register to this session. And given that, if you are happy to take over, Robert, I will be in the background to support you anytime. Okay,
cool.
Let me just activate your screen in this case. Okay, enjoy this session.
All right. So, well, first of all, I have an ultra-wide screen. So if you see the black borders here, I'm sorry. That's just how it is these days. I'll try to figure out a way to do that in a more suitable manner at one point. Yeah, like I said, my name is Robert, and I work as a cloud architect at Crayon here in Oslo, Norway. I am a HashiCorp ambassador for my work with Terraform, and I'm trying to be as active as possible with community things. So I'm doing these talks. I am the founder of the Norwegian PowerShell user group, so I do that as well. And there's more things coming soon. I'm also doing stuff with the Cloud Native Computing Foundation, where I'm in the working group for GitOps, the GitOps working group. So doing a lot of cool things there. So just in general, doing a lot of cool things. Feel free to come talk with me about it on both Twitter and LinkedIn or whatever you feel like it. By the way, I am looking at the chat on YouTube. So if you have any questions, just yell them or write them in the chat, and I'll try to get them as soon as I see them. I'm going to have a couple of slides, and then I'm going to go over to showing some actual code and hopefully have a little bit of a discussion about how Terraform does stuff. So, right. So why should we create modules? So when you start with Terraform, you kind of look at how the resources work, and you put together your Terraform file, and everything seems to work. So why do we need to put stuff in modules? Well, first of all, I just need to clarify that everything in Terraform is a module. If you have Terraform in a file and in a folder, that is seen as a module. If you run Terraform in that folder, that is considered your root module. So your root module should be something that you can read and kind of understand easily. So one of the reasons why we create what's called child modules is to simplify the root module, so you don't see have like several thousands of lines of code, but maybe refer that you're gonna use code from somewhere else. And then you come to the principle of dry, which means don't repeat yourself. That's the standard thing in software development. If you are like me, coming from like a sys administrator type role, and doing more of the operations parts, that's a new concept maybe for you. But in like software development, keeping stuff dry. Don't repeat yourself. If you have code that's going to come several times, put it somewhere where you can refer to it, right? Also, you have things like fast initial deployment. If you need to create a new environment, you already have some of the code tucked away that you can just bring up and get started quickly. Pedro asked if I'm gonna share this slide anywhere. Well, I can. Actually, I will do that. I'll get the link out somehow. All right.
Just to let you know, Robert, usually we share relevant materials related to the sessions on our GitHub repo. So yes, we'll share I'll share the link for the GitHub repo, and then you can share whatever you want there. Okay.
Cool. I'll shove that up there then. So how should we create modules? Okay, we know that we want to create modules, but how should we create models? And throughout the years that I've been working with Terraform, people have had this kind of like, should a module have all your logic, set in stone, or should it be more flexible? My suggestion is that we want to try to keep things flexible, but also opinionated. And by that, I mean, for instance, we kind of want to steer people in the right direction. We want certain things to happen in your Azure Kubernetes service cluster, or your VM should probably look like this. If you're going by best practices and patterns, we should have an opinion about how that works. But at the same time, we need to be able to break through that, and we can't autopilot this, because at some point you have a scenario where you need to break free from that mold, so to speak. And one thing that keeps on popping up every time I talk about modules with people and I see other people's modules, remember there's more than one type of variable. So variable or input variables, if you want to use the full name, is just a way for you to just like in programming, put a placeholder name somewhere which you can put a text into. So really short explanation of that, but most people just use the string variable, a normal string variable, and that can get kind of messy. But what you also can do, you could use maps, you could have lists, you can have a certain object that's defined in a certain way. There's several different type of variables that you can use. Feel free to explore some of that. Don't just go for the variable and the name of the variable is a string, put it in, right? One thing that pops up if you want to be a little bit flexible is the conditional expressions that we have in Terraform. So this is an old concept where you have a condition, and if that condition is true, then you get a value, or if it's false, you get a different value. As we can see at the bottom picture, we have the pod CIDR part of the network profiler, where we're asking or looking at the variable network plugin. If it is KubeNet, then we want to use that variable. If it's not, we set it to null, so non-existent, right? And these things can be used for a lot of things. For instance, you have the problem with Kubernetes versions in AKS. If you look at what the documentation says, I'm sorry, it's a little bit small here, but I'll read it. This is an optional attribute, and if you don't set it, it will use the latest recommended version at the time of provisioning, and then never upgrade. Do we want Kubernetes not upgraded? No, we want it to be upgraded as fast as possible, preferably. I know big deployments that more or less just put out the new version as soon as possible. There are safeguards and everything like that, but still that's sort of how we roll with it. So how can we do that while not having the user having like a bad experience trying to get the versioning right? So the way that I kind of solved this, or I'm not sure if I even solved it, but the way that I did it is using 3 variables and a data source. So we have here a variable set Kubernetes version, which means that as the name implies, you can set a definitive version. So if you have a certain version that you want, cool. Every time you run Terraform, that will happen. But and you can upgrade by updating the versioning. When it comes to Kubernetes version prefix and Kubernetes include preview, that's something that I use for the data source at the bottom here. So as we can see, we're referencing a data source called the Kubernetes service versions, which looks at the location of your deployment and see what is the current version, the latest current version that is in use. And then we use the version prefix if we want, for instance, the latest version of 1.0. So if 1.19, sorry. So if the latest version of 1.19 is 1.19.28, just saying numbers, that will be the current version. And you can, say even 1.1, and then, if it, well, now it's 19, but at the time when it was 13 and 14 came out, it will take 1.14. Pedro says, careful about breaking change. It happened twice on K8s. This is why you're using a managed Kubernetes service, right? The latest version in AKS is not usually the absolutely latest version of Kubernetes. It has been worked on by Microsoft. It's been tested, etc., etc., etc. Obviously, things can go wrong there as well, but I trust the latest version of Kubernetes that has gone through the looking glasses of Microsoft, right? Sorry. So yeah, we got this data source, we got these variables, and putting them together, we get this. So for Kubernetes version, I'll see if a Kubernetes version, the Kubernetes _version variable is set to not set, which if you look at here, that's the default value. So if you don't set anything, that's the default value. So if no one has done anything with Kubernetes version, it will look at the current latest version of Kubernetes based on, again, the Kubernetes version prefix and Kubernetes include preview. And at the time that I took this picture, 1.20, not available. It was 1.18 before that, and I kind of just, every time I put out a new version, I kind of look at is the market ready? Is 1.19 going to be the next the release that I want to have set for everything? So that's just how it is at that point. If you don't like that, you could obviously change that by defining the variables differently. So that's conditional expressions. So you have dynamic blocks. This is also an example from the AKS or Azure Kubernetes Service cluster resource, where you have identity and service principal. These two don't, mix well, right? The first one says, I want my identity to be system assigned. Microsoft should fix that. And then you say, by the way, the identity should be the service principal. Obviously, these can't coexist. And how do you put that into a module if those can't coexist? So this is where you use dynamic blocks. So the way that I solved this was having a dynamic block for identity, where for each variable, for each of the service principal variable that is set to null, aka a service principal is not, have not been defined, I put in the system assigned on the type on the identity block. It's a little bit weird to read, but you get used to it. But basically, instead of having a block called identity, you have a dynamic block with the name of identity, and then you define the content of that block. The reason why we have for each loop here is just that's how dynamic blocks work, because you might have a list of things that you want to go through, etc., etc., etc. But what we're doing here is just saying, if this statement is true, so if the service principal variable is set to null, we create a list of one item. And it doesn't have to say system assigned. I just usually use what I set for type there. It could just be hello, a list of anything. And on the next line, the next dynamic block, we can see we have a service principal if it's not null. If service principal is actually populated, then we create a list. And if not, we create an empty list, aka the dynamic block is not going to be running. And then we set the client ID and client secret from that variable relatively easily. As you can see, we have an object here. So we reference the client ID and client secret, which is inside of the variables. So, all right, let's look at code. First of all, is this big enough text? Because for me, it's huge. I guess if no one complains, then everything's fine. All right, so I have two modules that I want to show off. Both are modules that are under, if you go to the registry, you can search for Crayon and you'll find these and you can use them. We use them at customers. We don't take any payment for having them there. We are actually using them. So if you don't want to create your own modules, you could find someone that will actively update that module, like what we do. So let's start at the AKS one because we already kind of showed some of this. We have, if we look at the variables file, we have a lot of variables, right? So this is what it takes to create a truly flexible module. It's not for the faint of heart, I guess. What we can look at, instead of looking at all of this, is rather look at where it's going to be used. So I try to separate these things into different files based on what resource it is, because, a bit bigger. All right, let's, I can actually look at the screen. Wow, all right, cool. I'll try not to, fall backwards. I try to split resources up in files depending on what resource it is. There's not a lot of resources going on in the AKS example, but in the virtual machine example, you're going to see that makes perfect sense. It's so much better having it like that. So if you look at, also if you hear someone scratching, it's my dog. It's trying to get down. So here we have our resource, which is the Azure RM Kubernetes cluster resource, right? This is what you would have had in your root module if you're just calling the resources, but instead, it's in here inside our module. As you can see, it's pretty standard stuff, right? We have, we're set a variable for names. We're doing the location, which comes from our resource group that we are creating. And that's usually created outside of the child module. So as you can see here, I'm using a data source to reference this. Probably don't need to. I probably could just have location as a thing and you put it in, but I'm going back and forth between complexity and this minimalists. I don't know what's best at that point. I guess it doesn't really matter as long as you just get the location in, right? And we're referencing the resource group name, which is the variable, which obviously then again feeds into the data source, which is why. So we can just say this is our resource group, we want to put it in, and the location gets there automatically. We have our tiering, SKU tierings. We have our DNS prefixes stuff, which in this case is just set to the same as the deployment name. Is that good? I don't know. I haven't had an issue with it. This runs at a couple of customers, and it works. DNS prefixes are just something to easily reference inside of a Kubernetes cluster. So who really cares as long as it's works? And obviously tags as well. And this can be a map of tags. It can be a big map, it can be a small map, doesn't matter. By default, it's set to null. And here we have the versioning, right? So we're just saying that if it's not set, we're going to get the latest version. And if it is set, and if it's defined as something, we're going to just use that variable. Easy stuff. We have some things related to doing some checks here, if it's there or if it should be set to null. We have again the network plugin one. This one probably shouldn't need to be there at all. Again, kind of experimenting with things. This is the great things about having version modules. If you change something fundamentally, you can still reference that old one if you have a cluster running that. Can be a little hassle to get that upgraded, but it works after some headache yak shaving. And then we have stuff like a role-based access control, which should be enabled. So if we look at everything that says good practice about Kubernetes, says the role-based access control should be set. So this is where I'm talking about the opinionated things. We have a variable for it. If we look at that one, it's a Boolean, and it defaults to true because it should. You absolutely should have role-based access control. That's default out of the gate for Kubernetes since a long time ago. So you should probably do that. And same thing with Azure AD managed. So that just means that there is RBAC. Cool. Should it be managed by Azure AD, which just means that you can put RBAC roles in Azure AD towards your cluster, and that will work. That will kind of solve things. What was the next one? And I also set that to true. This means that you have at least one thing that you kind of need to always do when you're creating a cluster, because if you are defining that Azure AD should be where your RBAC users come from, you need to have an admin group. So this is where you have good documentation on your things, and it kind of just says here that admin groups needed. So you need to put in an admin group. And then it does stuff. It checks if something is set to false. Then you should. If Azure AD manages set to false, you don't need to have the client, RBAC client app ID, and et cetera, et cetera, et cetera. Then we're coming into the fun part. So we have a default. So if you don't know Kubernetes, or if you don't know Azure Kubernetes, you have a default node pool. So that's the one that you have to have. Here I just define it. I've seen people doing it in different ways. So I just define a default node pool object, which have all of these things. Actually, let's just look at it. It's better to do that. Default node pool. So this is an object that has name, VM size, node count, enable autoscaling, min count, max count, and something called additional settings. I'm going to explain that. And by default, I put in what's considered kind of standard and just one node count, no autoscaling. At the current version of Terraform, you have these kind of, it get kind of silly at some point. You have this, if you define an object, you define min and max count, for instance, but you're not going to use it, right? You still have to define it. So at the moment, you have to set it to null. There is an experimental language feature that is hopefully it won't be experimental for that long, so we can use in production, where you can define a part of the object as optional. So min and max count could have been an optional value. Obviously, it won't work when autoscaling is on. Just kind of need that. But and because of that, you have these. If you put it in there, you kind of have to have it. I also put in something, a workaround, additional settings. which sounds silly, and I need to explain that a little bit more in the README files and everything like that. But as you can see here, it defaults to an empty map. But if we look at the default node pool, we have various additional settings, like only critical add-ons enabled, max pods if you want to set it to something else than the default, the OS disk size if you want to define that, and type and stuff like that. And then we're using the lookup method. So the lookup method is something that you can use to look and see if look inside a variable. So in this case, we're looking at default node pool additional settings and see if we can find only critical add-ons enabled, max pods, OS disk size, GB, OS disk type, and type. And these are just taken out of the documentation, right? So it makes sense if you have done this before, or if you created an AKS cluster before, you kind of know that these are the things that you want. If you can't find them, you set that to null, or in case of type, to a virtual machine scale set. So if this value exists, it will use that. So if additional settings, that map has only critical add-ons enabled, and then obviously set to true, then it will use true. If not, null, which makes in Terraform means that it won't exist. So this entire attribute will not exist if it's set null. Again, this is what you kind of have to do to have that flexibility, at least up until the point where you have the optional language feature. And then again, we go into dynamic blocks, and we're kind of talk through this and doing some stuff. If you want to look at this, just feel free. It's out there on GitHub /Preon/Terraform-Azure-RM-AKS. Got a little Sean Connery there, or go to the Terraform registry and you'll find it there. Then for the additional node pools, this is where the fun begins. So if you don't set any, if we look at the variables again, and additional node pools, we have again a list this time of objects, which looks like this. You kind of see the returning theme, and the theme that we have the name, VM size, everything that you kind of need. We have node labels. If that's null, then that's null. If we have node taints, and that's also if that's null, that's null. And we have a tags here. And again, everything needs to be defined. That's kind of the silly part. But if you don't want to set node labels, for instance, you'll just set null. Really looking forward to the optional one. And again, we have the additional settings. And this defaults to an empty list, which means nothing. Because here we have a resource, that's the cluster node pool. And we have a for each defined here. So for each cluster that we define that variable, we run through this block. So if it's 1, all right, it will happen once. If it's 1,000, it will happen 1,000 times. Probably shouldn't have 1,000 additional node pools. Well, I don't know, maybe you want that. So this gobbledygook thing just means that, well, if you see in a for each loop, you can kind of tell what's going on. So for each, and I have node pool in the variable, set and you sort it by the name attribute, and it goes through and you can use the each value here. Obviously, you need to define a setup against the Kubernetes cluster ID, which you have because it's created in the same module. So we just reference the one cluster that we have. If you want more clusters, you don't want to do count on several clusters in one module. So if you want more clusters, you'll do a new module reference to this. And we just go through and set for each value that's in this list, name, each value, size, etc., etc., etc. And then we have, again, if node taints apparently didn't like null, I think at this point, maybe that's fixed. That might be a language thing. So I probably should look if I can remove this and just have, if it's null, it's null. But I had to set it to an empty list. And again, stuff like enable node public IP, probably you might not want to consider that at all. So why even bring it in? So that's why it's an additional setting. I don't want people to have to think about that when creating AKS clusters and max files and et cetera, et cetera, et cetera. So same type of thing. So this is the Kubernetes module that we have at the moment. Works fine. There's some things that we probably should change, and there's some things that we need to put in and stuff. But in the end of the day, we have something like this. Well, actually, I've been doing local experiments. Seems. Ignore that. So all you need to do to create a Kubernetes cluster is have a module block, which is set the source, in this case, to our module, and the version that you want. You need to set you need to set the name. You need to set the resource group. You need to set the subnet ID. That's just because you need a subnet for things that are on networks. So that's just a thing. And again, as I explained here, we're defaulting to RBAC. Should probably say with AD, Azure AD, and that's why you have to set a admin group. And I have a resource group that I'm kind of depending on, et cetera, et cetera, et cetera. As we can see here, also I'm using, and this is strategy for data disks. Sorry, if you're, just looking at the recording. Pedro asked strategy for data disk on VMs. I'll get to it. That's a good segue. It could have been a good segue if I was done. Sorry. How I usually reference to several groups or a single group is just using the data source for admin groups, right? And I don't want to show that because that file has stuff in it. So I can just set it against a group by name, and that will find all the objects IDs, so I don't have to think about that, right? And obviously this is the easy one, and then you could do stuff like this, right? Defining a node pool, define the default node pool, et cetera, et cetera. So you have full flexibility to do whatever you want. That's kind of what we want to do here with the modules. All right, so looking at the Azure RM VM one, you can see here we have a whole lot. We have several files now, and the reason for that is we have. If you look at the Azure RM provider documentation, it used to be that we had one VM, resource for everything. But they changed that. And that's probably because it's so much easier to just reference Linux and the Linux resource and Windows in the Windows resource. And I kind of want to, glue that together again. I don't want to, be out at a client and then just start having like some Linux VMs and something. I want to say I want the virtual machine. It should be Linux based on the OS that I want, but who cares about that, right? So if we just, I don't even know how to start on this because this has a lot of things in it. So let's look at the variables, right? We have a name, resource group, everything like that. And we have several values here that I'm probably just need to, let's just look at the virtual machine for Windows. You can already see this is way more complex, right? And I struggle a lot with this. So if you don't want to do this, feel free to use this module, just saying. What I need to do is to figure out, what I needed to do was to figure out a way to actually define if the machine that I want is a Windows machine or a Linux machine. And as we can see here, we have on our Windows virtual machine resource, we have a count. And that just happened to be the only way to get that to work. So whatever. If this local and local, if you don't know, local values are just basically the same as variables, but you can define it locally inside of your you terraform to do some logic and try to get a result that you want, and you can use that later. So we're looking at the OS type. I'm going to show that in a little while. If that is Windows, we'll deploy one virtual machine that is a Windows, and then everything would follow. So let's look at the local. Again, this is a little bit so this is our OS type, right? And what it does is it looks through. Let's just do that so we have that all in one. We are looking at, let's just explain this the easiest way possible. We're looking at several different values here to figure out if the machine that we want to deploy is a Windows or a, by default, then a Linux machine. And the way we do that is I need a couple of things to look at, to reference. So I have the, that's actually local down there. So, that's actually something else. Sorry, I don't know why I mixed that together. First of all, I'm looking at the image ID OS. If you look at the variables, all right, so first of all, and the reason why I had to do this is because we needed to bring our own image. And everything was working fine up until that point, and then everything went haywire because all the logic was based on looking at one variable. This is why we had the logic. So if you are bringing your own image ID, instead of just putting the URI in, which is the normal way of doing this, I chose to have this as an object where you define the OS. So the first thing we look at is if we have the variable source image ID, and if that is if the OS attribute in the object is set to Windows. And if it's not, it defaults to Linux. And if it's non-existing, it will be Linux anyway. So now we have like the one check of Linux, even though it's not. Then we're doing the image. I have the local value called image reference OS, which looks at the next part, which if you don't define a source image ID, because at that point, that wins. This is how you define what kind of machine or what image you want on your machine, right? And this is what you do when you're creating a virtual machine in the portal or with PowerShell or whatever. So we have the publisher, offer, SKU, and version. And by default, I set it to well, not latest and greatest, but almost latest and greatest version of Ubuntu server. So image reference OS, if that dot offer is set to Windows server, which is what you would set if it was set to Windows server, any Windows server version, the offer would be called Windows server, which then means Windows, right? So we have if we are deploying Windows, we have now image ID OS, which says Linux, and then we have image reference OS that says Windows. And which one of them do we use? Well, if source image ID .os is set to null, non-existent, then I know for a fact that the logic here doesn't matter, right? So that's when I set the image reference OS as the current value, which would be Windows, preferably, or maybe, and or Linux if you actually set if the offer is Linux, then it is Linux. And if this OS attribute is set to something, anything really, it then references to this local, which would be Windows or Linux, depending on what it is. So you can see how complex this kind of gets. It took me a while to get this working. But that just means that the OS type is either defined as Linux or Windows, depending on these sets of logic. So like I said, if you want to do this yourself, feel free. I would prefer to just copy this. So we have our count value here based on what OS we have. If it's the Windows one, we'll get this one. We're referencing a network interface ID. This just means if you define your own network interface IDs, which means you created your network interface outside of the module and you want to put it in here. I don't know why you want to do that. Maybe you need to do something weird with the network interface, and you have one defined in a certain way. So you can define that. If not, you can just say, I want it in this in a certain subnet. So if you look at that, just really quickly, I'll try not to use that much time on this. But if this is not set to null, then you set that. If it is set to null, then you'll go through the how do I explain this? All right, let's look at it in practice, because it happens here, right? This is the network interface, and again, now we have two resources. So for those at home counting, we have two resources. So this is a whole lot more complex than just Kubernetes, which, you know, Kubernetes should supposed to be the complicated one. And we define, if we have subnets defined, we go through every defined subnet and create a network interface that is located in that subnet ID, and we create our network interface for that subnet. So if it's two subnets, we're going to get two NICs, one in each subnet, which makes it easy, right? You just say, I want a machine. It's supposed to be in this subnet. You don't have to think about it anymore. Cool, right? Hopefully that's cool. Maybe I'm just a nerd. OS disk, again, we have some things that we kind of want to define. And we have, if you look at the variable OS disk, it's a lot of back and forth, sorry. But imagine how this worked for me while writing this. We have this object with caching, storage account type, and optional settings again. And this is fine, right? For if you don't define any OS disk, you'll get this. That works. For most cases, if it doesn't, you know, you feel free to change it. And then we can, if you do define in the optional settings one, the OS disk size, we'll get that, and, you know, the encryption set ID if you want that, or even name. Who really cares what the OS disk is called? Right, so that's OS disk. I swear I'll get to the data disk soon. We have the boot diagnostics. Again, this is something where, well, if you define it to a certain storage account, that's cool. If not, it just needs to be nulled out. And then we have the plan, which takes care of if you want to, for instance, have HashiCorp Vault or any other product that's in the marketplace, you know, you can define the plan from the Azure Marketplace, and, you know, you'll have your virtual machine set up based on that. So you can even use Azure Marketplace things here, and there's zone and availabilities and time zones and stuff like that. And again, the source image one, this is null if nothing else, or if it is, you'll use that. And if so this one is easy, because if this is set to null, it won't run, right? But then we have the dynamic block that kind of looks at if we have the OS not set to, or if it's set to null from the source image one, we need to run the dynamic block with the source image reference, which does the reference. Why do you use Azure Virtual Machine instead of Azure? Yeah, so Azure Windows Virtual Machine, the Azure Virtual Machine is deprecated and will be gone. I think they're supporting it through version, the major version 2 of Azure RM. As soon as it's major version 3, that one is out. And they split it up into the Windows virtual machine and the Linux virtual machine. So again, like I said, this makes sense in many ways. But what I wanted to do here is not having to think about that at clients. I just want to have my one module that does everything, instead of having one module, instead of having two modules, one for Linux and one for Windows. It will be a whole lot easier if it was like that. So So trust me, that's if you want to have one module for virtual machines, please use this one. It was really hard to do. Again, you have specific things here like SSH keys, right? And other than that, it's more or less exactly the same because they work in the same way except a few things, and that's why they split into two, but I have no clue. All right, so far we have either one resource for Linux virtual machines or one for Windows virtual machines. I think I'm going to use all the time just explaining this. And then we have things like, I'm first going to do if you want your machine Azure domain joined, Azure domain. If you want your machine Active Directory domain joined, that's an extension. That's also a resource. So here we basically just says if it is not set to true, then we have ADDS set to true. I don't know why that's explained, but it actually works. Weird. Anyway, so this creates an extension on the virtual machine, which if you use extensions in Terraform, you just have to define your the settings like you would in your extension in the portal, I guess. And this more or less just says that if you can define the domain name, the user that want to use, and the password for that user, and that user should have be able to domain join computers, the organization unit path, and a restart and options. A restart one is do you want to restart the machine or just domain join it? And the options, I actually have no clue. It's just a value. I set it to that value. It works. Everyone that I work with go like, yeah, cool. So if you want to domain join your computer, you can do that. If you don't want to do that, that's fine too. So this is like I said, you're putting everything into one basket here and making it flexible enough. Data disks. Pedro, how do you do data disks? So data disk is yet another resource. So you can see that everything here, more or less, would have had to be in your root module. So your one Terraform file would have all of these things, right? You had, now I can just say I want a machine and it needs to look like this. So this is why you create modules. Data disks. Again, I have let's actually look at the data disk variable. I have a variable called data disks. Description, any extra data disk defined as a list of objects. That's precisely what it is. You have a list of objects that has a name, storage account type, create option, caching, LUN, disk size in GB. And if you put this into that list, if you have one or if you have as many as your virtual machine can have, which is up to 16, I think, on the data, I have no clue. Anyway, for each one that you have there, again, we do a for each loop on that and create that disk. And as you can see, it actually is two resources. You have one resource to create the managed disks, which have stuff like the create option and disk size and stuff like that. And then you have to have a resource that attaches the disk. So again, we need to go over and do that. And here we're doing some magic, more or less, where because we need to actually reference the data disk in the list. So here I'm referencing the Azure managed disk, the name data disk, and I'm doing a toString, which creates a string out of this value, and we're referencing the name that's in this this object. So when you create this virtual the managed disk, it will say in the Terraform state file, it will say Azure RM _ managed _ disk dot data _ disk, and then since there's a lot of them, it's using the name here to list them. So every one of these, since the name is the one we're going by, will have in square brackets the name. So since we have a square bracket here, and we're doing this two-string name, I think that has something weird reference. I think that's why I need to do it like that. Anyway, by doing this, we'll be able to reference that. This managed disk. I don't know why I'm pointing to the screen. You can see that. And again, we need to define which virtual machine we're going against, and that's kind of hard to do if everything's dynamic. Or we'll just say if it's a Windows disk, we're going to reference the Windows virtual machine. And since we're doing a count there, counting starts at 0, so we'll always be referencing to 0. So same with the virtual machine here. We'll only create one virtual machine, so it will always be there. And then you can see the London caching is actually not even used in the data disk. And this works. We have had databases servers where we just needed to add a bunch of disks, terabytes upon storage, and you'll just update the list of data disks, and it says, here, I have a data disk. So that's actually kind of cool. Other than that, we have things like backup, right? So that's yet another resource. If there's a drinking game for every time there's a resource made, this module is kind of heavy. So, drink responsibly. Again, we're just looking if we have the variable backup. If it's not set to null, it is set to 1. So I'm going back and forth between these. I could have just, done this, but for some reason I like to explicitly say something. And if it's not set to null, I could have switched it around. I could have said equals null, etc. Take it with a grain of salt. Do whatever you want. It doesn't really matter as long as the result is what you expect. All right, I've been talking a lot. Anyone having thoughts, questions? I'll drink a sip of water. So. If not, this is just like a commercial. Don't create your own virtual machine module. Use this one. And again, these are on the Terraform registry. You can just use them. Need to digest those data disks. Well, we can have you can look at it again. Like I said, you have to use two resources, and if you need to do this in a module, feel free to go to GitHub and the repository for this module and just copy this. It's open source for a reason. The everything that you need to know to get this to work is these two resources, because you have the disk that you create and you have the attachment, right? And if you look at or I actually had that there, and then you just need this variable, just set up like this. Yeah, you got to practice. It's if I started this even let's say a year ago, if I started trying to create this a year ago, I would. Some of these took me a while to get, and that's with practice. I use Terraform daily at several clients and for my personal things, and still some of these things really bugged me, especially, and you can see that in some of the releases. I have released some version that says this should work, and it's like, no, it didn't. Damn it. So like I said, feel free to just use anything you find here, or just use the module itself. It's pretty easy peasy. I don't have an example here. That's on my to-do list, right? Sorry. So I kind of wanted to just show off the minimal required, but I don't have one. But needless to say, you just need to define a couple of things. You need your name, you need your resource group, and you need your location. So in this case, I just said, give me a location. Every time you do something that creates more complexity, it gets harder to keep track of. And this module absolutely doesn't need any more complexity than it's already present. And you need to define either a subnet for the machine to live in or a network interface ID that this machine will use. And I think the reason why, you kind of need that if you're doing, what was it? I needed to define something on a network interface, which, is kind of hard when it's behind the bars of this module, and I can't force everyone to do everything, right? So at some point, there's some things that you need to do directly against a network interface. And in that case, you might need to do that outside of the module, which means you'll have an interface ID. And by doing this, you can just refer to that or just put in a subnet. All right.
Hi, Robert. Jumping in.
Hey.
Long and intense session, but definitely really insightful on Terraform. And thank you so much for your delivery. I can see that a lot of people definitely are enjoying the session. And that's amazing. That's what we are here for, to deliver value and share knowledge with the community.
And it doesn't get nerdier than this. Also, like I said, there's several hours behind at least this module. So if people learn from my mistakes and my sweat and tear and sometimes blood, then that's perfect.
I actually have a few questions for you, coming from, of course, from a person that which background is not DevOps but development, but definitely working in the last years on Azure. I have been working several times with ARM templates, and it comes always the question, because you see Terraform, Ansible, and Bicep, ARM templates, and so on. So many names, and if I understood correctly, one of the things that definitely the Terraform brings is the portability, right? So independently on the cloud provider, you can use your templates, your Terraform templates to deploy resources. Is that correct?
So Terraform has its own language, which basically is just a simplified JSON, right? So it's like in the background, it actually also takes JSON, but it has this HashiCorp configuration language, which is what we're seeing here. And it's Terraform is totally vendor agnostic. It doesn't matter if it's Amazon, it doesn't matter if it's Google, it doesn't matter if it's Microsoft Azure, it doesn't matter if it's Oracle, it doesn't matter, et cetera, et cetera, et cetera. Even on-premise things, it doesn't need to be cloud things. It can be backup solutions, it can be Kubernetes itself, et cetera, et cetera, et cetera. The same way of doing things work with all those, and that happens through the provider. So in this case, we're using the Azure RM provider, which obviously is the Azure Resource Management provider. There's also an Azure AD provider. So if you need to do things with users and stuff like that, there's a different provider for that.
Okay. So now the question comes, of course, this portability brings some delay in terms of, I imagine, in terms of compatibility. So as an example, that's ARM templates and even Azure Bicep nowadays, Microsoft promise 0 time delay in terms of compatibility. As long as you have a service available, you have already compatibility available, and it's supported by ARM templates and Bicep. So in this case, I believe that's the drawback, right? So on using as an example Terraform or any other portable.
So yes, but because in the middle here we got the provider, and the provider is just more or less translating Terraform things to API, right? So it's just talking to the API. However, as with all the major cloud providers, Microsoft is working with this provider, this Terraform provider. So what they have, for instance, I think is on the AKS code, they promise at max a 2-week delay for any new features.
Yeah, that's fine.
So in most cases, during those 2 weeks, you probably haven't gotten around to actually, having checked all the boxes that you employ to get the new feature in anyway. So I see that as kind of trivial in that sense. And like I said, ARM templates are complicated, and you got Bicep on top of that, which makes it easier. But at the same time, then you're kind of just learning something that would only last you up until a point where you go out of Azure.
Yeah, makes sense.
With Terraform, you kind of get everything in the world if you want.
Yeah, totally makes sense. And so, yeah, let me just, in the meantime, just share again the screen here quickly before we close out. And again, I just ask everyone, if you did not register before, you can scan the QR code in the screen or even use the link in the chat, and you can register to this session and access relevant materials provided by Microsoft. And comes another important moment as well. Let me just share here with you. So it's time to share, if you enjoyed the session of Robert, of course, it's time to share a bit of love. And I will share a link to a forms where you can basically use that link to just provide feedback about the session of Robert, and feedback ultimately about what we are doing here, And I hope you enjoy. And that's it from my side. No more questions, Robert.
All right, cool. Thanks for having me. It's really fun.
No, it's a pleasure for us, and I hope you enjoyed, and I hope for sure you will come back and deliver more sessions to us, okay? And share your knowledge with this community. And
Absolutely.
of course, everyone, wish you a great day. Go watch some football. Euro is here. So yeah, time to watch some football and potentially drink some beers. The ones who will enjoy beer, if not wine, or if even water, maybe.
I don't enjoy football, but I can drink beer. That's fine. I'll do that.
So see, there is always something to everyone.
Yeah.
All right. So take care of you and have a great day, everyone. Thank you so much, Robert, once again. Take care.
Bye.
Bye-bye.